Welcome back. Let's take a look at finding the domain of radical functions. So let's start off with looking at interpreting whether or not we have an even or odd index. So for part A, I would like to point out that we have ourselves an odd index. 7's an odd number. So right away, if it's a radical function and we have an odd index, we have a quick way to find the domain. It's automatically all real numbers. So we could say negative infinity to infinity. So right away, done. Really nice, huh? Now, if you look at part B, you'll notice it's almost the same function, except for there's one thing missing. If you notice, you don't see an index. So remember, that's implied that the index is a 2. We also call that a square root. But if the index is 2, we have ourselves an even index. And if we're interpreting what's the domain of a radical function with an even index, it's basically all numbers except for those that make the radicand negative. Now, if you want to find this analytically, which I always recommend you do, we're going to set the radicand, which in our case, it's 6 minus 5x. You set it greater than or equal to 0. Then you note what type of inequality that you have. Always be careful. I know that this is a linear inequality. So depending on what type of inequality you have, you would take the appropriate procedure for you to solve this. So if you look at the 6 minus 5x greater than or equal to 0, solving linear inequalities is kind of nice. All you have to do is isolate the variable. So this would allow us to, we would subtract 6 on both sides, leaving us with negative 5x is greater than or equal to negative 6. And now if you're going to divide both sides by negative 5, let's do that. That's going to leave us with x on the left. And remember, if you divide both sides by negative, that inequality symbol is going to reverse direction. So this is actually going to give us x is less than or equal to. And negative 6 divided by negative 5, we can leave it as a fraction if we'd like. Just kind of make sure you know that it's a positive number. So this gives us an idea of what our domain would be. If you want to be formal, I might be a little more formal. You would label this, if we're doing this in set roster notation or set notation, I'd be looking at all numbers x such that x is less than or equal to 6/5. Or if you're looking at interval notation, you would say it's negative infinity to negative 6/5 with a bracket on the 6/5, a parenthesis on the negative infinity. Now let's just double check these. Sometimes with your TI, you can definitely verify using some of the techniques we talked about from chapter 1. So I'm going to pull up the TI real quick, give us an idea. I'll erase my previous writing. And what I want to look at y equals. Let's go to remember what we were supposed to type in. Part A was the 7th root of 6 minus 5x. So going back. I'm just verifying for myself. If I want to type in a 7th root, I can type in a 7, then go to the math key and type in the x root. That's item number 5. And right away, it shows me the index. So that's the 7th root of 6 minus 5x. And if we were to graph it, see what we get, you can kind of see that it doesn't appear to have a break in all the values of x's. I know sometimes the calculator is a little bit tricky, especially when you see the It looks like there's a little hole there, but there's not. And we're trying to use our knowledge of the fact that we had an odd index. So automatically we've got ourselves all real numbers as the domain. So that's kind of nice to see. And if I were to change this up a little bit, just to look at part B, here I'm just looking for the square root. So I'm gonna, let's see if it gives me there. So square root of 6 minus 5x. If we were to graph this, you start to notice, oh, if I scan myself, or if I'm looking on the x-axis, I see for negative values of x, there's always a function above me. But at some point, somewhere around +1, all the values of x do no longer give me a function. And so this is why it's really important. We realized when we go back and we look, it was an even index. We can kind of estimate what that value is, but we can go back to analytical methods to find that precise value of x that's going to give us the stopping point of our domain. So if I kind of can pull that back for you to view, we found that precise stopping point to be 6/5. So that is around +1, but we have the exact value. So I hope this gives you a little bit of perspective. We'll go over what happens when the radicand is a little more difficult in a next example. So I'll see you then.